first thing we're talking about today in the atomic structure is what makes up an atom. So what is the atomic structure? So we should know by now from previous lessons and earlier years that you've got the nucleus of an atom, and then around the outside we've got these electrons whizzing around, and that's where we've got the electron shells. We talk about these orbital paths, and you may have heard, and later on you'll see at higher levels, that they're not really an orbital path, it's really an electron cloud, but we draw it and represent it by these rings of how far out they are. So within the nucleus, we've got two major things. We've got protons and we've got neutrons. So neutrons being neutral, protons being positive. Most elements, atoms, etc. are neutrally charged, ideally, because you've got this plus balanced out with this minus. We can add and subtract neutrons, and that gives us an isotope. So we can't change protons. If we change protons, we change the element. If we add a proton to this, I chuck another proton in, and then in theory another neutron, I've now got hydrogen, I've now got helium, 2 and 2. If I add an extra neutron, it's still helium, but it's now an isotope of helium. It's helium with 3 neutrons. So, protons, neutrons, electrons. That is our atomic structure. When we talk about nuclear forces, we've got two main types. We've got the electromagnetic force, and we've got the strong force. We've also got the weak force that we sometimes refer to as strong and weak, but the main ones that we talk about for this course are the electromagnetic and strong force. So firstly, if we look at electromagnetic, that is the force responsible for attracting and repelling charges. So if we got two charges that are the same, they'll push each other apart. If they're different charges, like a positive and negative, they're attracted towards each other. And the thing that actually creates that attraction is the electromagnetic force. A bit like magnetism, but in this case it's electromagnetism. So if we had a positive proton and a negative electron, they're opposite charges, so those things are going to attract. They're going to pull into each other. They want to be together. So that's your opposite. If you've got the same charge, like two electrons do not want to come in contact with each other. So they are going to push each other apart. So that's your EM force, the electromagnetic. When we look within the nucleus and we go to neutrons and protons, neutrons don't have a charge. So the electromagnetic force has nothing to do with it here because there's a positive and no charge, so it doesn't care. This is where the strong force comes in. So you can think of the neutrons as like nuclear glue. They stick the nucleus together. All those protons and neutrons are glued together. And this bond here between the proton and neutron, that attraction is what we call the strong force. And it's a huge force, which is why we creatively named it the strong force. So this bond is why when we split these things apart, and we'll talk about that a bit later on, why we get such a release of energy from that break, because it takes a huge amount of energy to break this in the first place. So that's your electromagnetic force, and this is your strong force.